All right, so good afternoon, everyone. Today we'll be looking at reactions of aldehydes and ketones. We'll start off with just a brief overview of aldehydes and ketones, looking at how we assign them, describe them as functional groups. So we'll start off with just nomenclature, right? So if we have aldehydes, so we're looking at aldehydes and ketones today. So we're looking at aldehydes and ketones. And we'll start off by just looking at nomenclature, right? So if we take our aldehydes, for our aldehydes, we'll take our E ending, and the E ending changes to an AL. And then for our ketones, right, we'll take our E ending, and we'll replace it with ONE. Right, so al and on are how we'll identify our aldehydes and ketones, right? So you can imagine that if we had some carbon chain, so I've drawn an aldehyde, I'll also draw a ketone, right? You should be able to name these molecules, right? So these are really small organic molecules, not a lot of substituents present there. So you should be able to name this molecule, and we're looking for our longest carbon chain, and we'll start numbering at our substituent. So now we have, this would be carbon 1, 2, 3, 4. We're starting to number our substituent of priority. In this case, it'll be our aldehyde. So this would be, since we have 4 carbons, it would be a butane. Okay, so it'll be butanol would be the name of that molecule, right? And you can imagine that if we added some substituents on carbon 2 and 3, we could change the name. So if we add chlorine on carbon 2, and let's add a OH. Nope, not an OH. let's keep it simple. Let's add a chlorine, and then let's add a Br on carbon 3. You can imagine that now we'll have, we will still want to alphabetize, so it'll be 3-bromo, 2-chloro, butanol, Al would be the name of that molecule, right? And then for our ketone, we're just taking our E ending and replacing it with ONE. So that means that, and we also need to indicate where the carbonyl is located in our chain, right? So this would be a 1, 2, 3, 4, 5 carbon chain, and we want to give our ketone the lowest possible value. So this would be 5 carbons would be pentanone, NONE, and then since our ketone is at carbon 2, it would be 2-pentanone for that molecule, right? Right, so you should be able to kind of go through the naming. Other things to notice with our naming is that we want to, if we have an aldehyde or ketone, right? If it's in a ring, so aldehydes in rings, we'll call those carbaldehydes. Right, so an aldehyde in ring is a carbaldehyde. And then if it's an aromatic ring, then we'll call that benzaldehyde. Right, so if we have an aldehyde, if we have a ring and we have an aldehyde on our ring, that would be a carbaldehyde. And then for a benzaldehyde, we have an aromatic ring, and then there's a hydrogen in there. Right, so if we were to think about kind of just drawing these molecules, they would be those molecules I've drawn here. So another thing that you should, I would say commit some of it to memory, is the spectroscopy information for aldehydes and ketones. So if we look at our NMR data, so NMR for aldehydes and ketones, For our proton NMR, the hydrogen for our aldehyde is really deshielded. It's strongly deshielded. Right, so it's strongly deshielded, and it normally appears between 9 and 10 ppms in our proton NMR. And then for our carbon NMR, for aldehydes and ketones, this carbonyl for aldehydes and ketones, so our C double bond O, we'll see a shift around about 200 ppm, right? So if we think about just general aldehyde and ketone NMR information, that's where you'll see your signals occur. So if we were to look at some example molecules, so let's take an example aldehyde. Right, so I'll put a CH2 here, and then I'll put a methyl here. If we were to think about the chemical shifts in terms of the carbon NMR, right, so just looking at our carbons, then the chemical shift for the carbon that's a part of our aldehyde would be around, in this case, 201.8 ppm. The carbon that is our alpha carbon will be around 36.7. And then lastly, our terminal methyl carbon will have a chemical shift of around 5.2. Right, so these are all the chemical shifts there. So that would be our aldehyde. And then for our ketone, if we want to draw a ketone species, right, remember that our ketone will be a carbonyl. A carbon should be there, and then there should be a carbon on either side of our carbonyl. So let's put a few more carbons on our molecule, CH3. And now if we want to indicate the chemical shifts here, right, the carbon that's still a part of our carbonyl will still be around 200, 206.6 parts per million. And then the chemical shift for a terminal methyl will be 29.3. For our CH2 in the alpha position, it's going to be 45.2. And then the carbon, the chemical shift for the carbon here will be 17.5. And then as we get further and further away from our carbonyl, we see that our chemical shift gets smaller and smaller. So this would actually be 13.5, right? And all of these are in parts per million. That's our, ppm. Those are the units that we have on our NMR, ppm, on our NMR scale. All right, cool. Any questions about that so far? All right, so the basic overview of aldehydes and ketones, right? So we can make aldehydes and ketones from alcohol. So if we oxidize an alcohol, right, we can make an aldehyde or a ketone. So one straightforward example, if we have, I like this example because it's a ring opening reaction, right? If we have a ring, so if we have a ring, right, we can put a double bond in there, add a methyl, CH3. And then one way that we can generate our aldehydes and ketones, if we just use O3 ozone, right? And then in the second step, have some reducing agent. And we'll go over what a few of those are. We can make a molecule where we have ring opening occur. So we'll open our ring. And on one side of the molecule, we should get our CH3 methyl, right? There should still be a CH2. We should have 4 of them. And then on the other side, we'll get our aldehyde, right? So in this case, if we were to just track where our carbons are, you can imagine that if we were to number our carbons, this would be carbon 1, 2, 3, 4, 5, 6, and 7. And then this would be carbon 1, 2, this would be 3, 4, 5, 6, and then this would be carbon 7.
Jade, I have a quick question.
Yeah.
On the so on where it says, does that say 5.2 on the far left on that methyl?
Yeah, that's 5.2.
Okay.
Yeah.
Thank you.
Yeah. It's really upfield there. Yeah. Okay. Cool.